We are going to go on to 3.2 today. All right, with 3.2, we are going to deal with translation or transformation of graphs. Your book calls this families of graphs. I like to call it this because this is literally what we're doing. We're going to look at how different manipulations of these parent graphs we talk about create a family of graphs. And these are translations and transformations. So what is that going to look like? Well, if we think of your standard form of just saying, if we were to say y equals f of x, all right, I'm going to start with one of the basic ideas that I've used over the years to explain what we're talking about. And it's this idea. If I had y equals plus or minus some value a, this is a constant, times a function where I have x plus or minus some value of b, and then plus or minus, again, some constant c. So a, b, and c are constants. These things, each of these things, this plus or minus, this a, this b, or the c, affect the actual graph. All right, now let's talk about that effect. And I'm going to kind of work through some examples as I talk about the effect. So first thing, the first effect we're going to talk about is this plus or minus in front, right? That plus or minus that goes in front here. That's this one. All right, that plus or minus tells us something, and that is going to be telling us whether we reflect it or not. And I want you to get used to this word reflect. All right, we talk about flipping all the time. I hear kids tell me that a graph is flipped. Flipped is very non-specific. It could mean anything. We are going to talk very specifically about a reflection across the x-axis, all right? And that happens when we have a negative. So for example, if you had y equals x squared, that is the plus version of this, right? We have a positive that's implied in front. You know that graph is a parabola going upward. Okay, so now what if we have instead y equals negative x squared? All right, this is a reflection that makes the graph go downward, still at 0, 0, and then going downward both sides. This is a reflection. We would say this graph is reflected across the x-axis. All right, I want it to be very specific because what we've done is take that graph that was here and we took each point and reflected across this line of symmetry, this line of reflection of the x-axis. So it is reflected across the x-axis. All right, I want to be very specific. Again, we're going to look for this wording, guys. Absolutely the same thing as what that says there. No variation on it. All right, then we go to this a. This a that we're talking about is outside the function. All right, I say it's outside because what we're going to have is this is multiplying whatever already has happened in the function. All right, and I think that's easier to see when we talk about it. Anytime it's outside, I want you to think of a vertical transformation. All right, this is a vertical transformation always. Vertical being the key word here. All right, now, what does that mean? Well, let's use the function we just did. Y equals 2x squared. I say it's outside the function. This value of a here is 2, right? This is our a value. It's outside the function because we're first going to do the exponent. We're going to take whatever our x is that we're plugging in, we square it, then we multiply it by 2. It's a very specific order there of operations. It's outside the function. It's happening after the function squaring happens. So what happens to this function? Well, we know from our previous work that this graph, instead of going over 1 and up 1, would go over 1 and up 2. And so this graph would expand vertically. It would be stretched vertically. Now, stretching is not a good mathematical term. So what I want you to think of this is we want to talk about a vertical expansion. All right, it's already vertical because it's outside, right? So it's a vertical expansion by a factor of. It's important you use this terminology, by a factor of. It's not vertically expanded by, it's by a factor of. And you can abbreviate this as BAFO, just so it's not as tedious to write out. By a factor of, in this case, whatever a is. So this would be vertically expanded by a factor of 2. All right, that's what it means to be outside, and that's what it means when this is true. It's a vertical expansion. When this value, this is when a is greater than 1. All right, very key point there. That value is greater than 1. So what if it isn't greater than 1? Well, what if y is equal to 1/2 x squared. Well, now we still have it, it's still vertical, and it's now, instead of an expansion, we're going to call it a compression. And the reason we're calling it a compression is, think of the graph. This graph now, if I plug in an x value of 1, I would go plug it in, it would be 1, then I multiply it by a half. So it's only going up this far. It's going up a half instead of over 1 up 1, it's over 1 up a half. If I go over 2, where normally I'd get 2 times 2 is 4, it would go over up 4, it's going to go up half that, it's going to go up 2. So this graph just starts to spread out this way more, right? It's like it's been pushed from above. It's been forced and kind of compressed. So it's a vertical compression by a factor of A, whatever A is. And that is when A is between 0 and 1. Okay? So a vertical compression by a factor of A. Next, we go to B. B, the B value is inside the function, right? It's inside here. All right, so we're adding or subtracting inside. When we have this inside, and this creates a translation, all right? And that translation is going to be going side to side. When we have the value, this constant is inside the function and it's added or subtracted, we get a translation. What does that look like? Well, let's look at another function. You know the absolute value function, so let's use that one. If I had, for example, absolute value of x plus 2, all right, this plus inside is going to tell us that it is moving left. It's the opposite of what we think, all right? It's going to move this left by whatever value b is. Plus gives us left b. So this would be left 2. Our absolute value function would move left 2 over here, because if I put negative 2 in here plus 2, that's 0. So it gets me that 0 again, and it would still go over 1 and up 1. So we'd have our absolute value graph, right? Now, what if I had instead y equals absolute value of x minus 2? Well, now when we talk about a negative inside, right, and this is inside again, this would be right b. So this would be right 2. If I graphed this, I would go over 2 and then put my vertex, that center piece, and then I'd go over 1 and up 1 and draw my absolute value graph, right? That's what the graph, how it would be changed. It would be moved or shifted left b or right b. And so you can say shifted, or you can just tell me it's left 2 or right 2. That's fine too. All right, those are much easier to describe. And that leaves us with our last translation, our last change in this graph, and that's the C value. And the C value is outside the graph being added or subtracted, or outside the function, sorry, being added or subtracted. So this is outside. And outside, we again have a translation, right? It's a plus or minus outside. I should probably do that. So we know it's plus or minus outside, and this is a translation. Again, now this is going to move us up or down. So that would look like this: y equals absolute value of x plus 2. What does that do? Well, now moves us up. So plus here on the outside means up whatever value c is. So what would our graph look like? Well, we'd move up 2, and then we'd go over 1 and up 1, right? We'd be centered here, and we would have this graph here. Same way if I say y equals absolute value of x minus 2, well, minus means down the c value. So this graph would move down 2, and then it would go over 1 and up 1 here and here. We'd have this, right? So that's how this first one operates. Now, there's going to be another example of this. All right, this is where we have A inside. This is the key difference between this and some other functions where we get A outside. All right, when we get A outside, my basic function, let's get a new page. My basic function will now look like this: y equals plus or minus f of ax plus or minus b plus or minus C. So we have a difference here. I will tell you there's no change here. All right, the plus or minus there will still reflect it. The negative will reflect it across the x-axis. No change here. This is still going to be going up or down, right? Plus is up, minus is down, C. The difference is going to happen with A and B here. With A, this is now A inside, right? If you remember before, when we talked about A, if I go back here, A was outside. Well, now we're looking at A being inside. When A is inside, it's no longer vertical. We go the opposite direction. We talk about it as a horizontal transformation. Okay, so now it's a horizontal transformation. What does that look like? Well, let's use some of the functions we know. Let's use, let's do something different. Let's just do absolute value. That one works well. Let's do y equals, and I'm going to have absolute value of 2x plus 3. So what's going to happen here? Well, what I want you to think about is we want to see if this graph moves left because of the plus, right? We know that. But what does this 2 do to it? Well, the 2 inside, think about what's happening to our graph. The 2 on the inside is now saying, all right, if I was at 1, normally I would be saying, all right, well, I'm going to move left 3 and it'll go up twice as fast, right? So there's kind of this weird middle ground here where what is the A doing here? Well, it's going to be, I want you to think of it this way. I want you to factor this out as, well, you know what? I may have gone too far too fast. Let's just do just this function. I think I'm going to confuse you if I do this too quickly. So let's do this first. Let's just deal with just an A, not an A and a B. All right, I'm sorry. Let's just do this. Y equals 2x. Now, what's different about this? Before, remember when we looked at 2 times x squared, the squaring was happening first, and then we were going to multiply by 2. Well, what's happening here? I plug in my x, I multiply it by 2, then I take the absolute value. So this puts the A inside, right? So the A is inside now. What's going to happen to this graph? This is easier to see, I think, than dealing with it the other way. We'll get to the B and an A combination in a minute. All right, so what's going to happen here? I'm still going to be 0 is going to be 0. But when I move over 1, what happens to it? I do 2 times 1 is 2. Absolute value of that is 2. So it goes up here. So this is what it's going to look like. It's going up faster, isn't it? So now I said I'm using a horizontal here. This value of 2, we're talking about horizontally now what's happening. What's going on with this? Well, if you think of it, the normal graph was doing this, right? What we're doing is pushing that in to create this new graph. So this is going to be horizontal. And it's going to be a compression. It looks like a vertical expansion, right? If you go back to what we did here, when I had 2 times x squared, the 2 meant we vertically expanded. Well, this is going to be now with A being greater than 1, this is going to be a horizontal compression. A greater than 1, we horizontally compress. It's the opposite of what happens. It looks like a vertical expansion, but it is a horizontal compression. All right. A is greater than 1. Now, again, this is going to be by a factor of, but this is where it changes. It's 1 over A. So we're going to say a horizontal compression by a factor of 1/2 here. All right. It looks like a vertical expansion by a factor of 2, but it's a horizontal compression by a factor of 1/2. A little bit different idea, just different words, guys. All right. And a different kind of, I guess, metric. All right. Now, what if I go the other way? What if I said y equals 1/2 x absolute value of that? Again, this is inside. This is an A value inside, so it's horizontal automatically. Now, what happens to this graphically? Well, normally I'd be going over 1 up 1, right? But now if I put 1 in, I multiply it by a half, I get 1/2. And absolute value 1/2 is 1/2, so I'm here. When I go over 2, I put 2 in, I get 1. So what's happening? Our normal graph would have been going up through here. Our graph is now going out here, right? So what's happening horizontally? It's not being compressed now. Now it's being expanded. So this is a horizontal expansion by a factor of. Again, we're going to use 1 over a when it's horizontal. So this would be a horizontal expansion by a factor of 2 because a here is between 0 and 1. So again, this looks like a vertical compression, but it's a horizontal expansion. And you have to be able to tell that by whether the A value is inside or outside, whether they use horizontal or vertical. Very important point. And you'll get practiced at this and it'll be better. All right. I like doing this way first. Now let's deal with B. So with B and an A inside, now let's deal with that one I was just talking about. Y equals, and let's do a squared. Let's do, just to make it look a little different. All right, I'm going to do 2x plus 3, that quantity squared. We know this graph normally, we're talking about a squared graph, that's our parabola pointing up. All right, this 2 inside. What I want you to do is immediately think of this way. Just like I showed you, I started to show you last time. All right, the reason I say do it this way is it tells us the true B value, the true shift, and it tells us what our A value is. This makes A 2, like it still was here. It looks like A is 2, right? So this is inside though, so it's horizontal, right? This is still a horizontal and it's a 2, so it's a horizontal compression. And it's going to be by a factor of A still. I'm sorry, 1 over A, because we're doing horizontal. So this is by 1 over A. And the difference is going to be when we do this with the B value, we're going to talk about this as shifting left by, well, it's going to, you can see it now. Well, I did not want it right there. You can see that it's plus 3/2, so that's left because of the plus, it's 3/2 as that shift. Instead of seeing it here, it looks like it's left 3. It's not, it's left 3/2. So how do I do that? Well, let's do it in general terms. It's going to go left B over A. Because what we get when we factor this out is we divide that value by A. So it's left B over A. If this was minus, it would be right B over A. All right, so what's that going to look like if the value is, let's say, 1/2? So if I have y equals 1/2 x plus 3, that quantity squared, well, again, I'm going to do the same thing. I'm going to say y equals 1/2. And that's going to be, well, let's change everything in this. Let's make this minus, so we do that. All right. Minus. So this would be x minus, well, I divide 3 by 1/2, I would get 6, wouldn't I? And that whole thing is squared. So now I would know this is horizontal because it's inside the operation. Remember, we're multiplying by 1/2 before we're squaring. So this is horizontal immediately. And it's going to be expansion because this value is between 0 and 1, right? So it's horizontal expansion by a factor of 1/2. I'm sorry. I keep reversing that. It's going to be 1 over 1/2. So we're going to do it as 1 over A. So this would be 1 over 1/2. This would be vertical or horizontal expansion by a factor of 2, right? And this would go, because it's minus, this would go right. For us, it'd be 6, but we're going to call it B over A. All right. So what does this look like? Let's see. Let's go. I'm going to just mark that this was plus and this was minus. So that's in the notes. Sorry. Now let's do some examples. Let's put all this junk together. Let's start looking at some ugly ones. All right. So if we had something like this, it asks you to describe the transformation. Describe the transformation. Let's say transformation, translation. Oh, spelling is challenging for me today. I'm getting very dyslexic in my writing. Translation, describe the transformation translation of the parent graph. Or from the parent graph. You could say it either way. I think your book uses of. But all right, so they give you something like y equals 1/2 absolute value of x plus 3 minus 2. And they want you to describe that. Well, the parent graph of this, what they mean by that is this. Parent graph is y equals absolute value of x. That's what the original graph looked like. We've done all sorts of things to move it and stretch it and do all different things to it. So we want to describe those mathematically. We want to use good mathematical terms. So the first thing I'm going to look at is this, the 1/2. Well, this is outside, right? This is outside, and the value is between, our a value is between 0 and 1. So this is going to be a compression vertically. So vertically, automatically, because it's outside. It's going to be a compression because the value is less than 1. It's by whatever that a value is, by a factor of. Let's just use BAFO. I know you guys are going to want to use that. You're not going to want to write out by a factor of every time. So by a factor of. Do not just say by 1/2. That will get it marked wrong every time. It's by a factor of 1/2. All right, so that's the first translation, or transformation in that case. Now we look at the plus 3. Well, the plus tells us what? Plus means it's going to the left. And it's moving 3. Because it was outside, we don't worry about the a affecting this. Then, last, we've got the minus 2. Minus 2 tells me it's going down 2. And we have that set. All right, that's the transformation translations to that graph, to the parent graph. All right, let's do another one. Let's do, oh, I want that. There we go. Y equals, let's do an unusual one. Let's do 2 over x plus 1. Now, I want you to think of this way. This is 2 times 1 over x, because we're going to do that and then multiply it by 2. All right, plus 1. That's the way I want you to think of this so we can get the right words. So what's happening? So 2 is outside. That's our a value. 2 is outside, so automatically it's vertical, right? And it's a number greater than 1, so that's a vertical expansion by a factor of whatever a value is, in this case 2. Plus 1 tells us up 1. That's it. Now, in contrast, what if I had this? Y equals 1 over 2x minus 3. Well, now I want you to think of this as y equals 1/2 times 1 over x, so you get the words right. Because now, what is this? Well, if I do it as 1/2 x, I can talk about this as a vertical expansion. The problem is, what they're going to say is, this is slightly different than this. All right? So what I want you to do, this is the first instinct of everyone, but what I want you to do is instead think of it this way. All right? And I don't know if I said that the right way. I wanted to lead you there to see if you think of it like this, but what we're really doing now, this one we were going to multiply by 2 after we did 1 over x. Here, the x is kind of in the function. We're going to do 2x and then do 1 over it. All right, so this is inside the function. So what I want you to think of this is that 2 is the a inside. So if it's inside, I don't even have to draw this again. I don't have to rewrite this in a different way. I'm thinking of it this way because it's inside. It's multiplying the x first. So as soon as you see it inside, what do we have to say? It has to be horizontal. Yes? And if we're talking about this being multiplied by 2, instead of, like with vertical, that would have been expansion, right? But what are we going to talk about it here? That's going to be a horizontal compression because it's going to pull it in. A horizontal compression by a factor of, well, this is 2, so it's going to be by a factor of 1/2, right? The 2 is on the inside, so we have to say it's horizontal. It's compression because with that value, again, once it's inside, we know that if it is greater than, well, did I write that out for you? I don't know if I wrote that out for you. Let's go back for a second here. I want to make sure I wrote that out for you. We did this here. We did a horizontal compression by a factor because, oh, I did write it out for you. All right, I wanted to make sure. When A is greater than 1, we do it by 1 over A, right? When A is less than 1, again, we do it 1 over A. This, in this case, was, let's go forward, horizontal compression by a factor of 1/2, right? And then it's going to be down 3. All right, just because the -3. Now, this one is one of those that people have struggled with over the past, but I want to be clear that when we do this, it's how you think of what's going on, where in the function is versus outside the function. So again, with this one, when we have it on top, we think of it as outside the function. We have it underneath, it's inside the function. All right. So again, I want to be clear on how we do that. All right. And then we have, let's do another one. Let's do this one. Y equals, this is going to be, what do we want to do? Let's do 2x plus 5, that quantity squared, and then -1. So again, first thing I'm going to do with this is rewrite this as x plus 5/2, that quantity squared, -1. All right, so what do I have here? I have 2 that's inside the function, right? So inside automatically tells me that I've got horizontal. All right, this is going to be compression, right? Because it's greater than 1 by a factor of, and it's going to be 1 over, because it's horizontal, we do 1 over A, so that's 1/2. We have positive inside, so that's left, and it's going to be 5 over 2, so left 5/2, and then down 1. So hopefully you start seeing these changes, and they're going to ask you a variety of these questions, and we can adjust as we go. The general rules I want you to follow, go back to this stuff. All right. When you have it, the only difference, what you first have to decide when you first see these functions is the A inside or outside? When it's inside, we're doing horizontal. When it's outside, we're talking about it as vertical. All right. Then when it's vertical and A is greater than 1, it's an expansion. When it's the horizontal and it's greater than 1, it's the opposite, it's compression. Same thing here. When it's between 0 and 1, vertically, oh, I didn't put a T in there. Vertically, it would be compression. Horizontally, if A is between 0 and 1, it's an expansion. All right. So those are our general rules. We're going to deal with a lot of different graphs. You're probably going to have some questions. Struggle through these guys. Work through them. We'll go over the answers tomorrow. And good luck. Have a great day. I will talk to you tomorrow.